Let's say that we have a particle that's traveling in one dimension, and its position as a function of time is given as t to the third power plus 2 over t squared. And what I would like you to do is pause this video and figure out what the average acceleration is of this particle over the interval, the closed interval, from t is equal to 1 to t is equal to 2. What is this? What is this going to be equal to? So I'm assuming you've given a go at it, and the first thing you might have realized is we're trying to take the average value of a function that we don't know explicitly yet. We know the position function, but not the acceleration function. But luckily, we also know that the acceleration function is the derivative with respect to time of the velocity function, which is the derivative with respect to time of the position function. So the acceleration function is the second derivative of this, and then we have to just find its average value over this interval. So let's do that. Let's take the derivative of this twice. And before we do it, let me just even rewrite this so it's going to be a little bit easier to differentiate it. So if we just take each of these two terms in the numerator and divide them by t squared, we're going to get t to the third divided by t squared is just t. And then 2 divided by t squared, we could write that as plus 2t to the negative 2 power. And now let's take the derivative. So the velocity function, the velocity is a function of time, just a derivative of this with respect to time. So it's going to be derivative of t with respect to t is 1. Derivative of 2t to the negative 2. Let's see. Negative 2 times positive 2 is negative 4. T to the, and we just decremented the exponent here, t to the negative 3 power. And now, to find acceleration as a function of time, we just take the derivative of this with respect to time. So acceleration as a function of time is equal to, actually, since I've already used that color for the average, let me do a different color now. So acceleration as a function of time is just the derivative of this with respect to t. So derivative of a constant with respect to time, well, it's not changing, so it's 0. And then over here, negative 3 times negative 4 is positive 12 times t to the, let's decrement that exponent, to the negative 4 power. Now, to find the average value, all we have to do now, average value, is essentially take the definite integral of this over the interval and divide that by the width of the interval. So, or we could say, we could divide by the width of the interval, 1 over 2 minus 1, and this all simplifies to 1, times the definite integral over the interval. So 1 to 2 of a of t, which is, so that's going to be 12t to the negative 4 power dt. So what does this simplify to? Once again, this is 1 over 1. That's just going to be 1. If we take the antiderivative of this, and then we actually, well, so this is going to be equal to, the antiderivative of this is, so we're going to go t to the negative 3 power, but then we divide by negative 3. So an antiderivative of this is going to be, if we don't take the, well, an antiderivative is going to be negative 4 t to the negative 3 power. And we saw that over here. Obviously, if you were really just taking an indefinite integral, we would have to put some constant here. But in the definite integral, even if we put a constant here, it would get, if we assuming the same constant, it would get canceled out when you actually do the calculation. But the antiderivative of this, we increment the exponent, and then we divide by that new exponent. So 12 divided by negative 3 is negative 4. And we're going to evaluate that from at 2 and at 1. And so this is going to be equal to, when we evaluate it at 2, at the upper bound of our interval, it's going to be negative 4 times 2 to the negative 3 power. So it's negative 4 times, what is that? 2, that's 1 over 2 to the third, over times 1/8 is one way to think about that. And then we're going to have minus this evaluated at 1. So minus negative 4 times t to the negative 3. Well, 1 to the negative 3 is just 1. So it's just going to be negative 4 times 1. And this is going to be equal to, we're really in the home stretch now, this is equal to, this part right over here is negative 1/2. So this is negative 1/2. And this part right over here is positive 4. So positive 4 minus 1/2, we could either write that as 3.5, or if we wanted to write it as an improper fraction, we could write this as 7/2. So the average value of our acceleration over this interval is 7 halves. And if the position was given in meters and time was in seconds, then this would be 7 halves meters per second squared is the average acceleration between time at 1 second and time at 2 seconds.